Lussac's law is a gas law that describes the relationship between temperature and pressure. Its formula is P1 over T1 equals P2 over T2. An increase in temperature provides more energy to molecules. This causes molecules to move more. Thus, they collide with the container more frequently, which causes an increase in pressure.
We can see with this graph, as the temperature increases, so does the pressure. Therefore, they are directly proportional. If one increases, the other also increases. If one decreases, the other also decreases proportionally.
This is what we used.
A bucket of water, some food coloring, a candle, a beaker.
First, we filled the tub with a thin layer of water.
Then we place a candle in the center of the tub.
We then added a few drops of food coloring to the water so we could see it better.
Finally, we lit the candle.
We placed the beaker upside down on the water over the candle. We then watched the water level in the beaker increase compared to the water level outside of the beaker.
The beaker is filled with air particles. The heat from the flame gives energy to the molecules. The molecules thus try to expand, but since the beaker cannot expand like a balloon, the volume the molecules can occupy is limited.
This causes pressure on the beaker walls and on the water. The flame from the candle uses some of the air during its combustion. The resulting products are carbon dioxide and water vapor.
These new molecules fill the top of the beaker and force the air to the bottom. The candle then burns out because the air it needs to continue burning is now too low.
The flame is out, the air particles have a lower temperature and they lose energy. Because of this, they exert less pressure and want to have the same pressure as outside the beaker.
This causes a pull on the sides of the beaker and on the water. Thus, the water is pulled into the beaker.
That's why we can see the water level in the beaker increase.